Thank you everyone for joining us for like the last workshop in the series. We're going to go, we sent an email saying we're going over a couple of different topics. The first is the try except statements, and the second is passing objects into functions in Python. And then after that, we'll have time for either a couple different coding exercises. We can go over the graph problem from, again, like more without a time crunch from the end of session 2, or we can, if people did end up working on mini projects, we can like stop recording and just talk about those, or like help you debug those if you want us to, because we don't have a lot of new content. So if you have stuff you want us to review also, like feel free to just let us know. So the first thing we're going over is try except statements. And before we get into that, we're going to be reviewing the errors in Python. So last time, which was last year, we mentioned a couple different types. There are the syntax errors, which is when the code doesn't follow the rules of the language, so your program will not run because it'll be like, I don't understand what you're trying to do, and it won't run anything. You can also have another type of error, which are like during runtime. So these are exceptions in Python. So whenever you're trying to execute your code, it might like reach a line. It might be fine until it reaches like some line, and then you end up doing something you didn't intend to do, and it throws an exception and crashes. So in the bottom, like an index error, when you're trying to access something at an invalid index, or that could cause a exception. Yeah, and then there's also logic errors, which are normally silent, and these are when your program will have incorrect or unexpected behavior, and it'll likely throw an exception and it may not throw an exception and crash, but if you're lucky, it will. Otherwise, it'll be silent, and your code will run incorrectly, and those are harder to debug. So yeah, so I mentioned like index errors are one kind of exception you might see in runtime, and you could also have like a type error when you give a function, when your arguments have incorrect type, and you try to do like when you're trying to use a standard library function maybe, and you give it something that it's not expecting, it'll cause it to crash. So that's one thing to help against errors we can encounter in runtime are the try except statements. So why would you use them? You don't want your program to always crash when you run into errors, and especially during runtime, like you'll want to catch and handle those errors. So like one case we'll see later about using this is when you're asking the user for an input and you want specifically numbers. And let's say you're doing something with numbers after like multiplying them. If you tried giving it like a letter, if someone put in a letter and then you tried multiplying it, your program would probably crash. So we could use try except statements to first realize that we didn't get what we wanted. We didn't get an integer value, and then we could use that to make sure we don't reach that state, and maybe we'll ask the user again for a different input. So the syntax behind try except statements is you'll first always have this try clause, which is the statement that you're trying to run that could possibly lead to a crash. So whatever that statement that you think might lead to a crash, like taking an input, that will go here in this first try block. And then there's multiple ways to use the except clause. The first way is if you have a specific type of error that you're trying to catch, like a value error. What you would do is you would use except, and then you'd have the type of error, value error, and then this is what you would do to handle that. So you would be like, okay, like if I got that error, maybe I just want to quit my program. So you would like clean up everything and just you'd close it here, or you'd print out something. And then you could also use this clause where you have the type of error you're accepting, and then as error. So this is like a type. This will create a variable error, which is like, I think it's an error. It's like an object Python has to handle errors, and it'll have, so if you printed the statement like this, it would print out details about the error. And then you could also use this except clause without specifying what kind of error you're expecting. So like, let's say you try something and you get any load of different kinds of errors. You just want to do something to handle that. So you can have this just a try and just a plain except. They'll do whatever you want it to do, and you don't have to specify what kind of error to do this. It'll just, whenever it has an error running, whatever the statement is here, it'll do that. And then you can also optionally have this else clause, which will run if the try clause completes successfully. So if this doesn't cause an exception, then it'll just go to the else clause. And any number of these except clauses and else clauses are allowed. You can just choose which ones to use, but you will need you'll need to have the try, and you need to have some sort of except or else in there. But you don't need all of this. You can just choose what you need. Does anyone have any questions on that? Okay, so I didn't realize I had the slide here, but it's kind of saying what happens the way you flow through these statements, which I try to explain. So first it'll try what's in the try clause, and if there's no exception, sorry, 1 second. A value error. Okay, wait, a value error. Wait, we're going to look this up because I just had a moment. Okay, so for example, if you try to give sorry, I had to look it up. I don't remember off the top of my head, which is because it's been weeks. Value error is when you're trying to assign a value to some object, but they aren't compatible. So like the example they gave here is if you tried, I think they said if you try to put dog into int, it'll give you a valid value error because it doesn't know what to do with that or how to convert those. Whereas the int is meant to take types like floats, this int function, which will convert whatever you give it into a integer. It's meant to take things like floats or decimal numbers, and it could also handle integers, but if you give it a string, it doesn't know what to do with that, so it'll give you a value error. So yeah. Okay, I'm gonna go back to the last slide. Okay. Yeah, so was it clear how the statement flows through it? Or because I did go over it, but then the slide is also here that fully explains like the order it happens. Okay. So we had an example here, but we also have it in the collab notebook for this week, which we linked in for the sign-in sheet. So we're just going to go over there to do a few examples, and hopefully that'll help if anyone's confused about anything. So the first example is like a trivial case. You wouldn't actually write a program like this, but this is kind of just to show what it does. So like I have a list and it's empty. So like if I wanted to add anything to this list, I would have to use the append keyword, but instead I'm trying to index into the first element and assign it to a 1. So I know off the top of my head that's going to be an index error. So I'm going to use this try except statement to use this to print information about the error. So on the slides, we had this whole type error and this error. So when you have this print statement, it will print the type of the error as the index error. And it's a class in Python, and and then the error itself, this variable holds like the message, like list assignment index out of range. And then, so when it does that, we have it appending 1 instead of just trying to reach in and grab this 0th index, which doesn't exist yet. And then once we do that, we can print it and we'll see that, okay, like it did accept it and our program didn't crash because of this. We were able to catch this error and we were able to still do what we wanted to do. So that's like a trivial example. You wouldn't actually write a program like this. And then this example is the one that's in the slides, and it's from the Python documentation. So does anyone want to guess what it's trying to do? I could have kind of went over it. It's fine if you don't understand, we'll go over it. It's kind of complicated, but if anyone's like, oh, I know what this is doing. Okay, that's fine. Okay, so, oh, go ahead, yeah.
Is it it seems like it's like the user might be putting something in that might not be a number, like a dollar sign or a word, and then it's catching it as a value error. So then it prints that and it goes back through the while loop. And otherwise it'll just break out right after the input. Is that right? Okay.
Yeah. So we have this int function again, which we saw when I looked up the value errors. And if you give it something that won't satisfy this int function, it'll prompt us to go through here. So do you want to give me something to like enter in here? Does anyone want to just give me something that's not a number? Okay, yeah, let's do that. So I enter that and it's going to say, okay, it's going to try that. It's going to say, oh, I got a value error. So it got a value error on this line here. So it's going to go here and it's going to print this error. And since it's in the while loop, and it's an infinite while loop because it's just while true, so this will always happen. It will go back here and try to prompt you again. And this time I actually enter a number 1, so it can this int function won't raise an exception, so it successfully completes and it'll break out. So like they're useful. This is like an actual scenario you might find yourself using it versus the first example, which was just kind of a trivial case. Does anyone have any questions on try except? If not, I'll pass it on to Evelyn to talk about the next topic, which is passing objects as arguments. And let me know if you want me to switch over to the notebook or anything.
Okay, yeah, I'll do. Okay, so in Python, when we pass values into functions, they're passed by object reference. So that means Python passes a new object that holds the same reference. So in this example that we have here, I think that one we actually have in the Google Colab, right?
Or we do, but we also have spiffy animations that we can step through.
Oh, right, yeah. Yeah. So for this one, we start off with just saying the list, making a list that only has the number 0 in it. And then we call the next function append1 to the list. So the append1 function takes this list we pass in and appends 1.
Yeah.
And then finally we're going to, it calls the print function and it prints a list.
I'm just going to step through the animations. The pointers are still on this line, and we have like this object. The object reference just means that the object is in red, and these 2 green boxes are like the containers or like the names for it, and we're referring to the same object by potentially different names. So it printed list, and it'll print 0, 1. And do you want me to go to the Colab notebook?
Yeah, let's go to the Colab notebook.
Yeah.
Okay, so the reason that it prints 0, 1 is because when Python passes list into the function, it's sending the actual list variable into it. So when it's changed inside the function, it gets changed. The actual variable outside the function gets changed too, because it's all the same variable, if that kind of makes sense. So then in printing it, we have 0, 1 as opposed to the original 0 is created as. So it's like kind of different than say in some languages like C++, where it passes a copy of it instead of the reference by default. Does that kind of make sense? Okay. We go back to the slide. Okay, go back to the slides then, I guess.
Okay, yeah, that makes sense. Oh, these are wrong slides. Okay, here. Oh, this is different. This is the same one.
Okay, yeah, so I guess we already went through this example.
This one's the other one.
Oh,
This
never
is
mind.
separate
Sorry.
example.
Yeah. So does anyone have a guess as to what this would print? Yeah, that's correct. Because when we pass list in the function, it changes list's value outside the function. Oh wait,
That's
sorry.
not correct. That is not correct.
Wait, it's not?
It's not correct. No, because Python, yeah, so it is going to print just 0. It's not going to print 0, 1, because the thing about object reference is it's completely different than what you would see in like C++ or like what you're learning in your classes. When you have an object reference, so we have our, like for the past example, we had list, which is like our container, our variable name, and it's the object behind it is this thing in red, which was 0, it was initially 0 here. And then when we called append1, this list.append directly modifies the same object. So like appending it is a function of the object itself. So if that makes sense. So like this, whenever you call append, you're calling it on a specific list object. So here we have the same object 0, and now we're calling like the function that Python provides to interact with lists, and that appends 1 to it. But in the next case, we're doing something different. We're doing an assignment here, right? Instead of directly modifying the object, we're assigning to the list we had in this function the value of 0, 1. So we have it stepped through. We have it being stepped through. So like we have the first line, we have list, and we put in 0 as we did in the last example. And this time when we call reassign, what it does, when we first have this separate named list, this other variable, we have this named variable list, which is from the function. And what it does is assigning it just puts a 0, 1, like a separate object to this reference, to this object. Is it because the change is occurring locally within the reassign function, so the change wouldn't hold outside? Yeah, the change is holding locally within the reassign function. So if we tried to print it here, it would print 0, 1. But when we print here outside of the function, we haven't actually modified the original object by passing it to this function. So we actually would see that this prints, yeah, this would print just the 0. And we have notes here. Since this function reassign assigns a new value to the list with the equals operator, we create a new object in memory, which is represented by these red things in our slides. And then, yeah, be careful with using the same variable name in functions in Python. So like you might end up making mistakes and confusing yourself. And if you're confused, especially if you're like kind of confused about this, it's really easy to just write a short program. You're correlating it to pass by reference, and yeah, it's more like pass by pointer. It's called pass by object reference, and it's not the same as what you'd see in C. And if you do get confused in the future, you can always just try writing a short program to see what it does. And we can just run the snippet here. And yeah, we see that it prints 0. Does that make sense? I know this is kind of confusing, especially since it's not what you'd expect. Okay, I'm guessing people are okay with that, but it is a confusing thing. it doesn't really make sense intuitively. Sorry, I clicked the wrong button. At first, so just be aware that this is a thing when you're working with objects and passing them to functions in Python. And if you did want to like reassign something like this, instead of doing the equal sign, you would want to return list the new list and just save the new list as a returned variable instead of trying to do this and then wondering why isn't the new object I created available outside of my function. You could return it. Oh, how can you print the object that's passed into the reassigned? Okay, so if you can only do that within the you can do that within the function. So you can just go like this, print here, and oh, indentation's bad. And, okay. Yeah. And the fact that I called it a different name here instead of calling it list doesn't mean anything. Like I can call it list here too. And it doesn't yeah. So you can print it when you're in the function, but once you leave the function, you lose the variables. Like you'll lose whatever changes you made to it because it goes out of scope. Oh yeah, so what you'd want to do is you'd want to return list. And then if let's say like you did something like this and you like find it differently, you'd want to return list and capture your new list. You'd want to just capture whatever you returned. Okay, yeah. I guess, Evelyn, do you want to go over the coding exercises we have?
Yeah, do you maybe want to start with the first one and I can take it from there?
Okay, yeah. So we have a couple of exercises here that we can either, if you guys, would you rather do it together or like, would you like to do breakout rooms? It's up to all of you to decide. You can let us know what you think. Can we do it together? Okay, yeah, we can do that. So the first one is to write a program that will add the string ing at the end of a given string. So it'll take in a string and it'll have that string that it takes in will have a length of at least 3. And we want to add the suffix ing to it. But if the string already ends with ing, then we want to append to it the suffix li. So we have some examples. So like if we had a sample string of ABC, we would append ing to it. So it would become the string. But if we have something like string, which already ends in ing, we would append ly to it. And if it's something that's less than 3, then we can just leave it as it is. Does anyone have any ideas on how they would approach this? Without looking at the hint or with looking at the hint, that's fine. Okay, does anyone have any initial guesses? Do you want me to give a hint? Yeah, you'd need to do some form of checking for ing. And you wouldn't have to check for ly because we don't really care if it ends in ly. But yes, we need to do some form of checking for ing. Do you know how you'd want to do this checking? You would check for ing using a substring for the last 3 letters of the original string. Yeah, that's exactly what you want to do. And how would you check for these last 3 letters? Do you know how you do that? It's okay if you don't, but you might.
I can't remember how to do it in Python. Sorry.
Okay.
I don't know like C++, but
You're good. Okay, so I had these slides open for a reason here. So we can use slicing. So do you remember this notation where we had like a number and another number? So like if we had a string and we wanted to check the not the third, that would be the 4th through 6th element, we'd use the slicing notation. And remember that we could do this with negative numbers. So we can put in negative parameters here if we wanted to slice, if we wanted to start, if we wanted to start from the end, we can use negative values. So -1 would mean the last character, -2 would mean starting from the second to last character, and so on and so forth. So we could have negative numbers in like any of these positions. So, and then this third position is like the step. So like, how do you want to step between them? So like here, I'm just going to move that for now. This, if we had string 2 colon, it would print the characters from the third string character to the end, but we want to check the characters in the last 3 positions. So do you know how you would do that now? Did I review it clearly?
Yeah, no, that makes sense. Would you do like starting from like string length because you want to start, or string length -1 because you want to start at the last character, right? And then do like -3 or something? Sorry, I don't know if that makes sense.
I think you're on the right track. So let's say I had like, we have my string, right? My string, and you said you would want to start at the
End of the string.
end. Yeah.
Back 3.
Okay. So do you know what I'd put in here to do that? To
Would
get the last 3? Yeah.
it be like length my string -1 like before the colon? Wait.
Okay, so just if you want to say, if you just specify -3, you could do that. You could totally just get the length of my string somewhere and save it, and then you could totally just do length of like my string minus whatever, like -3 and -2. But there's an easier way to do that with the negative indexing in Python. So you could just go ahead and say -3.
Oh, okay.
So you could, yeah, so that would work, but you could just go ahead and do this, and this will tell Python that I want to start at the 3rd to last element in my string. So like if we had this as our string, then our 3rd to last element would be this P, if that helps.
Yeah, that makes sense.
Okay. So do you know do I need to put something here?
No, right?
No, yeah, you're right. You're absolutely right. You don't need anything here. I'll just go to the end of the string. So that's how you would access the last 3 letters. And what did we want to do by doing that? Someone said in the chat earlier they wanted to compare it. Do you know how I would do that?
Would you check and see if it's equal to ing?
Yeah, that's exactly what you want to do. So we would use if statement, and we just say if that is equal to ing. We put the colon here, and then what would we do?
What was the problem again? Like, was it add ly or something? If the
Problem was, yeah.
Oh yeah. So then if it does end in ing, then add ly to the end of the string.
Yeah, and someone had in the chat too. Do you remember the syntax for that in Python?
No, I'll be honest, it's been a while.
You're good. Does anyone else remember the syntax, or should I just go ahead and type it? I think
It's just plus equals.
Yeah, plus equals will work. The add function, it might also work. Let's just see. Let's check string library Python. I feel like that add function does exist, but I'm not sure if they got rid of that. I opened the documentation, but it turned out there's more documentation than expected. Maybe there is no add function. Okay, I'm gonna go with there's no add function to do that. And that's probably because they let us just use the plus equals operator. Sometimes some other data structures in Python will have like an add function, and I'll let you do that unless someone wants to correct me because they looked it up. Okay, yeah. Okay. So then that's if it ends in ing. What else? Do we need an else clause? Is there anything else we need to do?
Should we account for trying to check the length of the string to make sure that it's at least 3 characters?
Yeah. So where should I do that? When should I do that? How should I do that?
I guess you should probably determine whether the string is valid before you decide to append anything to it. So most likely before the if statement.
Okay. And then do you remember how?
Just like if, so like take the length of the string, and if that length is like more than or equal to 3, then you can just like continue, or else like it's invalid.
Okay, so if the length is greater than or equal to 3, you'd want to continue. But if it's not, what would we want to do?
Have them maybe like re-enter their string with a longer length, or just like, yeah, something like that, like start over.
Yeah, we could do that if we would do that. We would definitely do that if we had like an input, like if we're using the input function to do this. But since we're just passed in my string, we can just return out of this.
Oh, okay, yeah.
I don't know if someone said that in the chat. Yeah, you would. We're asked to return the string, right? We were probably asked to return the string, so you'd probably just want to return my string. You might not remember what the problem said, and so I'm gonna go back. If the given string is less than 3, we can just leave it unchanged.
Oh, okay. I didn't see that part.
Yeah, like I have the problem open on a separate place, so like I'm checking here, but you probably don't remember what it said. So yeah, this is fine. We can just return my string if it's less than 3, and then hopefully you all remembered that len is the way to check the length of a string or a list. But are we done yet? I feel like there's something missing, and maybe I should just go back to the problem for this. Yeah, the else. What should my else clause do? Wait.
I mean, it should end. It should add the ing onto the.
And you probably all know exactly how to do that. So I just typed it out. We should have let you guess, but yeah, that's exactly what you want to do. You just want to add the ing to it. Now, are we done? Did we do everything we needed to do and more? Should I switch back to the problem statement? Return. Yeah, you're right. I almost forgot that too. Return. Is there anything else we need to do? Or is this it? Yeah, this is it. This is what you would want to do. This is exactly how you would approach this problem. The main thing to like note about this, it was like the slicing was the tricky part. So you don't have to like always memorize how to do this, but just know that slicing is this, and that you can give it negative numbers, and you can always go back and reference it. And that just made our lives a lot easier instead of like trying to manually check each of the last 3 characters, or even calculate the offsets ourselves, like manually computing what this number should be using the length of my string. We can just give it a -3 and call it a day. And that makes it a lot easier. But yeah, you guys remembered and you did this one. So let's keep going. We have like 3 more problems, but maybe Evelyn can present all of them and then you guys can choose which one you want to do next.
Yeah, I can do that. Yeah, so we have 3 different ones. This first one is writing a Python function to construct the following pattern using nested for loops. So that's just doing for loops basically. And then the next one is one where we take in a list, which can have multiple copies of some elements, and we want to return a list that only has one copy of each element. So like that example, there are a bunch of 3s in that list, but we want to return a list that only has 1 3. And then the last option is one which takes a list in of n integers and returns -1 if the product of all the numbers in A is negative, 1 if the product of all the positive numbers in A is positive, and 0 if their product is 0. And like for a challenge, can we do this without multiplying all the numbers? Is there any preferences for which one we want to do first? And then we'll see how many we can get to with time. Like you can just do 2, 3, or 4 in the chat.
By 3, do you mean the one on the previous slide? Do you mean the one number 3, right? Okay.
Okay.
I'm going to stop sharing so that Evelyn can take over.
Okay, I'm seeing most requests for number 3, so I think maybe we can start with that one. And then I guess if we have time, we can go to 1.
Yeah. Pause share. How do I stop share? Stop share. Okay.
Okay. It's refreshing. Okay. So problem 3. So for this, we want to write a Python function that takes a list, and the list may have duplicate elements. It returns a list that has only 1 copy of each element in the original list. So I can just copy and paste this.
That's a good idea, and I should have done that. You can create a text block.
Yeah, I might
Soil
do that. Okay. So does anyone have an idea of how we might start doing this? Also, okay. Just also add this. So yeah, any ideas for how we could start doing this?
It kind of looks like a set, so maybe we can, or it's okay.
Yeah, I think we could totally be able to put elements in a set and then take them out again. I think we can also like maybe just create a new list and then start adding elements. I think it can be done like either way. I might kind of want to do the list example, but like I'm pretty sure it can be totally done with a set too. Or wait, Enrita, what do you think? Sorry.
Yeah, it can be done with a set. So if you remember the set function, which will pretty much, you can give the function that's just set with parentheses a list, and I'll turn that to a set. There's also a similar function list, which you can give it a set, and I'll turn that to a list. So you could probably pass you can just type it out. It's like 3 lines.
Okay,
And
yeah.
you can even test it and see that it should work.
So then you can do apply list. Wait, you have to
Yeah.
assign stuff. Oops.
Oh, yeah, I forgot about that. Use it.
Okay, so does anyone want to say what this next line would be, given that we want to use this list function? Possibly declaring a new variable. So like, do you guys know what we would pass into the list function? Yeah, exactly. We want to pass in the new set. And then is there anything else that we need to remember to do for this function? Yes, exactly, the return. So we want to return the new list. Okay, and we can test this out. We can call, wait, we can say call this list A, oops. We can say, or actually, let's just call this list B is equal to 1, 2, 3, 3, 3, 4, 5, like in the example. So then when we call this function on it, oh.
On anyway.
Yep. Yes, we get our desired output, which is the list, but only with 1, 3 in it. So that works well. I guess we can like either run through it the other way where we can just add stuff to a new list, or we could say go to problem 1. Any preferences? Yeah, sure, I can totally do that. I'll just create a new function for that. Code. Okay. So for this, we can start by creating our new list that we want to save some kind of output for, but we don't know what to put in it yet. So maybe we can start adding things to it. Does anyone like know how we could go about adding for things, like what kind of maybe loop statement we could use to add stuff?
Maybe like a for loop that'll go through each element of the old list.
Yeah, totally. So we can do for just say for A in old list. And then what should we do from here? Do you guys have any guesses? Like we can maybe do an if statement, but
If like the element we're currently on isn't found in the new list yet, then
yeah,
we
exactly.
can add it in.
Yeah, perfect. So we can say, or does anyone know the Python syntax for that? Involving a and new list, but some kind of comparison. And yes, exactly, not in. So if A is not in the new list, we want to put A in the new list. So does anyone know the syntax for how you would put that into the list? Yep, exactly, append. So A dot, new list dot append A. And then do we need an else clause, or does this do what we need to do?
I guess else would be like if it's already in the new list, then it just goes on to the next element.
Yeah. And in the for loop, when our if statement executes and it's not true, it's going to automatically keep on going. So we don't actually need to write an else
Oh,
statement,
okay, yeah.
but it basically, yes, that's exactly what we want to do. And then are we missing anything else from this function?
Returning the new list. Yeah.
Yep. Okay. So now that function's over, do remember to like tab out when you are doing code after a function, or else it's going to think that it is still inside that function. But we can run our test code, except this time we're calling unique list 2 instead of 1. And if we run it, we should hopefully see, yep, it's exactly what we expected. It removed all the extra 3s. So cool. And it looks like we have 10 minutes left, so I think we can try and do problem 1 for here. But before we go on, are there any questions about, I guess, either of these implementations of problem 3?
I was wondering if you were to apply try and accept here, like say if you got an old list but it wasn't really a list, like a number or something like that, how would you go about and implement that? Or is that too much?
I think for lists, they don't need to be the same elements, right?
They do
I mean,
not.
same types. Yeah, so
List elements can be any type.
you don't really need to like, I don't think there'd really be a case where there'd be a value error. So we kind of could maybe add in a statement, but there isn't really much we could do with it. Or would you agree with that, Rita?
Yeah, so if I'm understanding it right, your question was what if your list had elements that you didn't want it to have?
Oh, I was thinking more along the lines of if they instead didn't pass in a list and they passed in something
Oh.
else, like a
Mhm.
number.
Yeah, that
Yeah.
would be bad for this function. So you could, yeah. Did you want to? Do you think you have a guess where you'd put like the try or what would go in the try? And which version of the unique list do you want to work with? Just so we can choose one.
I think let's try number 2.
Number 2, okay. Okay, so where do you think this would fail if we didn't give it, if we didn't give it a list, do you think we gave it like a set or did we give it just like a number?
Wait, could you say that again, please? I'm sorry.
So so the question is like the problem is that we don't have a list when we wanted a list. So instead of a list, do we have another complex data type like a dictionary or a set, or do we have something like a string or an integer?
So I guess you would have to handle each one of those cases. Is that how that works? Oh, wow.
You could.
I see.
But actually, this code might actually do something useful if you give it a set, because right now, like so we have our old list, but if list was a set, we could still check if A is in the set, and we could still append it to the list. So this code would work fine if our list was actually a set. Does that make sense?
Yeah, I think that makes sense.
But if we gave it like an integer, then we would want to put in a try except statement just to like be like, okay, like we have weird users who might be using our functions like not as they should be attended, and they decided to give it an integer. So then we would want to put something in a try except statement. Do you know which parts would fail with this function? Because that's how we can decide what to put in the try clause.
I'm thinking the append might fail. Is that what might, or is it?
I think the append will be fine because we defined the new list ourselves, but something else might fail.
So would it be iterating through the old list?
Yeah, that
Hmm.
might fail if we didn't give it something that, if we give it something that wasn't iterable, like if we give it an integer, if we give it, dictionaries would work fine because you can edit if the in keyword is defined, but if you give it something for which the in keyword wasn't defined, it would fail. So that means this part starting at the 4 and probably everything in it too, because it's all encased by that for statement, would need to be in your try clause.
Hmm.
Because that's where it would fail. Did you want us to keep going with this example?
I
Do you
think
want
it's
us
okay.
to,
Yeah,
you're
thank you
okay?
for explaining.
Okay.
Yeah.
Okay. In that
Wait, can I
case,
just add on to that for
oh yeah, sure.
sorry, I just wanted to say that like you can put like try except in them, but also like Python does a thing where you can just literally check if like the type isn't it. So you can be like if old list is list, or you can be like if not the type of old list is int, then like raise an exception. Like Python, like when you do stuff like that, it literally starts to sound like English, like broken English. It's like if not type X is int. But you can just like check that in the beginning if you don't want to like look for other conditions.
Yeah,
Possibility.
that would probably be the better way to do it in this case too. You'd probably want to just check if type of old list is not equal to list. Then you'd probably want to like return. But you could also do a try except, like, but you'd probably want to do the type checking like Neha mentioned.
Yeah.
Thank you.
Yeah.
You can squeeze in problem 2.
Okay, let's see. Okay, so we copied and pasting this problem statement. We want to write a Python function to construct the following pattern using nested for loops. So I'll just copy this over. Oh, doesn't like that pattern. Is there any? Okay, well, we can just like look at this pattern. This is 3, 4, 5. This is 9 long, and at its widest, it is 5 wide. So okay, yeah. So we'll just have to know what that shape is because Python, I mean, the Google Collabs doesn't like to do special characters. So we need to fill in this logic. So for this, we're using for loops, or maybe one, maybe more than one. Does anyone have an idea for like maybe how many might be a good idea if we're trying to say make a shape like this? Yeah, 2 different ones. So like I guess the idea with this is you can kind of break up this into 2 different triangles where it's not too bad to make a triangle with a nested for loop, but a longer shape you do have to break up. So we can just say 4 and 4 since we want 2 different loops. So this first one could be for A in range of. Also, does anyone have like a guess, like if we're say going to try and break this, call this our first triangle, and then we'll have the first for loop associated with that, and then the second for loop, what our range would be?
Would it be 9 for rows? Oh,
Um, Yeah, it would be 5. So range gives the numbers from 0 up until but not including 5. So it would give 0, 1, 2, 3, 4. So that would work. But we just have to remember that it is all 0. So then with another, we want to do nested for loops. So we could say for b in range. And then for this triangle, okay, so yeah, once again, for this triangle, would there be a guess for like how many we want to do in the second nested one, which could say maybe correspond to how wide it is? Yep, 5 again. Or actually, yeah. Yes, that's a good point. It might, Kylan, or Kyan, sorry, I mispronounced the names, but yeah, I think that's actually right. We want to do for B in range A because we basically want to print this B wide. We want to print this basically B many times plus 1, but that, yeah. That was my bad, but thank you for catching that. Okay, so for this, we want to do, wait. So first, wait, and Rita, I'm doing this right?
Yeah, you're on.
Okay,
You're getting there. Yes.
Okay, sorry, just yeah. Okay, so now we want to print something out, but what do we want to print? So we can maybe make a string which we want to say print. Could say call this row. And do we know?
You can just go ahead and print it, right?
Wait, but
We
wouldn't
don't
the
need to
print
return
statement
it.
like create new lines?
Oh, yes, but there's okay, I see where you're going with that. You could do it the way you're doing it. You could also use, remember how we had the end? We could also do that. I thought you were trying to return it, which is not what you were
sorry,
doing. Sorry, that was on me. You're good.
Yeah, so we can do that. We can print just that symbol. We have to do this step first before end, right?
You don't need both. You can just use whichever ones you want to use.
And that's the syntax for doing that. Sorry.
Yeah, that's right.
Okay, yeah.
Google Colab's nice, and it tells you when you hover over it what the syntax is. And that's exactly right, yeah.
Okay, B in range A means that, wait, I'm just gonna add a +1. So B in range A means we want to start, wait, sorry. Okay, so that means we want to start at 0 and then print up until but not including A. And I want to do that A many times. Sorry, let me. It's like basically if A is 0, wait, I think it actually would be a +1. If A is 0, which is the first A in range 5, B wants to print in range of A +1. So A being 0, it wants to print in range 1, which means it prints 1 time. And then that goes until A's maximum number, which is 4. And in that one, B would want to print in range 4 + 1, which would mean it would print 5 different times because 0 to 4. If that kind of makes sense. But basically, I do with that being that we want to print 1 time for the first row, 2 for the second, 3 for the third, 4, and then 5.
Wait, I don't know if I confused myself, but are you sure we need the +1? I think because we're doing, it doesn't, if we do range 0, that will mean execute the thing inside the for loop one time. Because there's one element. Sorry, that doesn't make sense. If you do range, we can always test it, but
Yeah, we can
if-
always test it. We'll just test it. But yeah. And then after that, we do need a new line in order to go into the next row, which you could just do that by doing print and then a space. And then because the default end puts it to the next line, that can just create your new line. So we can test that to see if that prints the first part of the triangle by just calling pattern. Oops,
You forgot the
forgot
colons.
semicolon. Forgot
Me
colons.
too.
Remember to do your colons always. Yeah, okay. So we can compare this to the pattern we want. It looks like we only have 4 rows, but the rows we have look like it's going the right triangle pattern. So does anyone know how we could fix this to get a 5th row? I think that, so the A+1 says how many times to print this per row. So I think we want to, oh wait, actually, yeah, you're right. I think that would be the A+1. Let's try that out.
It's always useful to just run code as you're developing it.
Yes, that is correct. Okay. And in that case, we can also create spaces by just adding a space after that. So that way the string prints that way. And that way it looks like we have an exact match of this first half of the triangle. So the end statement, normally when Python executes a print, it prints everything that it wants to, and then it ends it with doing a new line. So like in C, you have to print a new line, but in Python, it just automatically does that at the end of each print statement. So when we do this end equals, that means we're basically changing what the default is, the default being the new line. So in this case, end is equal to just two quotation marks, which means like nothing in between them. So instead of doing a new line, we're just saying end it. Yeah, okay, cool. So we are kind of a little over time, but like I'm still down to like do the second half of the triangle, but like if people have to go, like it's totally cool, just yeah.
Fill out the feedback form though, please.
Yes, please fill out the feedback form. So yeah. Does anyone, yeah, no problem. Happy to help. Okay, okay, so for the second part of the triangle, does anyone like have an idea of like if we would start with the same code but change things, do something kind of different? We still want to do this nested for loop idea, but yeah, decrementing the for loop could totally do that instead. So we can kind of start off with something similar, but yeah, we can start off with something similar. And in order to decrement, does anyone know what we would do? So like, but maybe like, actually no, we're not actually decrementing the for loop, but like we want to start off with a larger, this internested one, we want to start off running in it a lot of times, but then decrease the amount of times with time. So like, does anyone have any ideas? Like maybe we could say, change what's inside the range function, with this, like it wants to make it larger, but then we could instead shrink it. Oh, also, it's not a,
Can we do something like for b in range like 5 minus a plus 1?
yeah, I think in theory that could do that maybe. Let's test it out and see what happens. Yep, that works perfectly. Yay! So that is the printing the triangle function. Does anyone have any questions about the implementation or just anything confusing in general? Oh, and Rita, I think you're muted.
I wasn't saying anything, so you're good. I was
Okay, cool.
talking.
Sorry. But yeah, does anyone have any questions in general? Or like specific to this question? Anything that can be helpful with?
For the second set of for loops, why is the outer one for a in range 5 instead of for a in range 4?
So for that, like, we can actually kind of see that we have this extra row here. So it so basically like for that last one, it just didn't print anything. So really we do kind of only need to run it for 4 iterations. Wait.
Okay,
sorry.
that makes sense. Thank you.
Yeah. But basically like just with the subtraction that we have in B, it got rid of an extra one. And so it looks like an empty row. So I think it could also work if we do in range 4 and instead we do 4 there. Yeah, it still works. And then this time, oh wait, no, that doesn't work. I think it would still be that 5. Yeah. So that would, the 4 works. It just happens to be a 0 in that last case. Yep, no problem.